Hello, welcome to the last lecture of week 2. In the previous lecture we introduced the concept of method of sections for determining member forces in statically determinate structure, determinate trusses. What we will do today is we will demonstrate method of sections through some examples. Okay, so today's topic is now let us first consider this example. Okay, now you need to find out the member forces in these members. Okay, now let us see this. Now this is the problem. Okay, we need to find out forces in member, some of these members. Okay, but we'll demonstrate the concept through some of the members, but other members also can be determined in the following the same process. Okay, we need to find out forces in member AB, this member, then member EF, this member, and BC, this member, BE, this member, and BF, this member. These 5 members we need to determine the member forces, right? Now let's first take and that we will be doing using method of section. This angle is 60 degree. This angle is 60 degree. Okay, let's first take a section here. Say this section is 1. This is section 1. Okay, now and take this part out from the entire structure and draw the free body diagram of this part. Okay, what will be the free body diagram of this part? Let's first draw this part. The free body diagram will be, say, this is member this is joint C, this is joint E, this is joint D. Joint D, we have a force, externally applied force P, and then here this is the member EF, and similarly we have here the member EB. This is EB and this is EF. So if we join them, this joint is actually B. Okay, and okay, now draw the forces. The forces will be, this force is in member EF, so this is F, EF. Now this is member BC, so there will be force, this is member F, BC. Similarly, we have a force in member BE, and this is F, BE. So this is free body diagram of section 1. This is FBD of 1 section 1. Okay. Now next step is apply the equilibrium condition on this section, on this free body diagram. Now if I apply the equilibrium condition, first we need to determine member force BC. Now if we take how many unknowns we have here? We have 3 unknowns. Now if we take, say, moment about E, then what will happen? This B will not contribute because its line of action passing through E. EF will not contribute because the line of action passing through E. So only force that will contribute is member BC and force P, and this externally applied load P. So if we write that M summation of M E is equal to 0. The forces, the moment about at point E is equal to 0. So this, if we take moment, if BC will produce anti-clockwise moment and P will produce clockwise moment, and all these distances are L. These distances are L, equilateral triangle. Okay. Now, so this gives us FBC is minus FBC, this distance is L, this is anti-clockwise, that is why it is negative, plus P into L, which is clockwise, this is equal to 0, and this gives you F BC is equal to 3 P. So, F BC is this. Okay. So, we have determined F BC. F BC is determined, right? F BC is determined. Okay. Now, what we next need to determine is member force in BE. Now, if we take summation of Fx is equal to 0, summation of Fy is equal to 0. So, what are the forces that will contribute? FBC is in horizontal direction, so it won't contribute. It won't contribute. P will contribute, it is in vertical direction, and the vertical component of B will contribute. Now, vertical component of B is in upward direction and P is in downward direction. So, this will be negative, this will be positive. So, vertical component of B will be F BE cos 30 degree minus P is downward direction, that is equal to 0. So, this gives you FBE is equal to 2 P by root 3, 2 P by root 3, 2 P by root 3. Okay. So, force in member BC is this. Okay. Now, next is when you determine force in member EF. So, BC is BE is this is done, and also we need to determine force in member EF. Force in member EF is summation, if you take summation of Fx is equal to 0, summation of Fx is equal to 0, and what are the forces will contribute? This force, and the horizontal component of this force, and those forces are minus FBC minus FBC, because this is this direction, and as per our sign convention this is negative, and then minus FEF minus EF, this is also negative as per our sign convention, and then again minus FBE, this is also the horizontal component of this force will be in this direction, therefore, it is negative, that is equal to 0. Now, from that we have already determined BC, we have already determined BE, only unknown is AF, and from this you can calculate EF is equal to minus root 3 P. Okay. So, this is EF. So, just by considering one section, we could determine the forces in member BC, forces in member BE, and forces in member EF. Now, remember, now you think if you have to determine these forces, member forces using method of joints, at least for this problem, then what you had to do is, first you had to consider this joint and calculate forces in member this and this. Once you have this, consider this joint, then calculate force in member this and this, and then consider this joint, calculate force in member this and this. So, you had to we would have we have to use free body diagram of 3 joints, but in this case just by one section we could determine the member forces. Now, still we are not done, we need to determine the forces in other 2 members as well, this member and this member as well. Now, in order to do that, let us take one more section, and that section is let us take another section, this section, okay, and let us draw the free body diagram of this section. Now, draw the free body diagram. Free body diagram will be like this. This is triangle ECD, then another triangle, this is BCE, and then AB, BF, and then EF. then F, and if you these are, this is D, which is force P, this is C, and then this is E, B, and if you extend their line of action, this is point F, right. Now, what are the forces we have? This will be the force member AB, then force in member BF, BF, and then here the force in member EF, force in member EF. What we need to determine? We need to determine the force in member AB and force and BF. This is already known because we have already computed this considering the other section. So, this is free body diagram of 2 2. Say this is section 2 2, section 2 2, section 2 2. Now, next take Fy is equal to 0, summation of Fy is equal to 0. The forces that will contribute to this is this vertical component of this, and this gives you, and this component will be negative and P is also negative because they are downward. So, this is minus FBF, these angles are, this is 30 degree minus P is equal to 0. So, FBF is equal to, if you minus 2 P by 3. Okay. Okay. Now, 2 by root 3. Okay. Now, then this is member this FBF. Okay. Now, next take, so AB needs to be determined. So, this is determined, AB needs to be determined. Now, if you take moment about F, moment, it is not that you have to see, if you draw the point F does not belong to this free body diagram, this structure, this part of the structure, but equilibrium, when we say the moment, summation of moment is equal to 0, means summation of moment about any axis is equal to 0 taken at any point is equal to 0, right. So, now if we take moment about point F, the advantage will be because this force and this force will pass through this point, they will not contribute, only contribution will be non-zero contribution will be from force P and force AB. So, if we take summation of moment about point F is equal to 0, then this length is L, these are L. So, P will produce clockwise moment and F will produce anti-clockwise moment, that is equal to 0, and then finally we get FAB is equal to 4 root 3. So, this is member force in AB. So, like this, if you have to determine the forces in other members, you can take other sections and continue this process to determine the forces in all the members. Okay. Now, let us demonstrate one more example. Let us see one more example. This example is example 2. This is example 2 and the previous one example 1. What you need to determine here is, you need to determine forces in member IK and forces in member HK, these two, this member and this member, you need to determine the forces using method of joints. Okay. Now, let us take, if I have to do this using method of joints, what you have to do is, this is the example that we have Okay. Now, if we have to consider again method of joint, then again you have to take several joints, draw the free body diagram of the joints and proceed. But let us see how using method of section this can be determined. Okay. Now, as I said earlier, for a problem, the best possible way is you apply both. Wherever you need, apply section and then apply joints as well in the same problem. It is a demonstration of that. Okay. First, let us determine the support reactions. Support reactions are draw the free body diagram of the entire structure. This will be Jy. This is Jx and this will be Kx, Ky. Okay. Now, take summation of Fx is equal to 0. Fx is equal to 0. Only forces we have in Jx and these externally applied forces. So, that immediately gives you Jx is equal to minus 120 Newton. So, this is Jx. Okay. Then if we take moment about J, summation of moment about J is equal to 0, then what are the forces which will contribute to this moment? All these forces which will produce clockwise moment, and then force Ky which will provide anti-clockwise moment. Okay. So, which will provide anti-clockwise moment. So, Ky, if you this gives you minus Ky into 7.5 plus, this is anti-clockwise, that is why it is minus, and then 40 into 2.7 plus this 40 into 5.4 plus another 40 into 8.1, that is equal to 0. Okay. And that will give you Ky is equal to 86.4 kilonewton. Okay. And then summation of Fy is equal to 0. So, vertical forces, only vertical forces are this, and this gives you Jy is equal to 86.4 kilonewton. Okay. So, these are the member forces, right? These are the member forces. Okay. Now, next let us take a joint, let us take a section like this. Okay. And then take the free body diagram of this part. If we take the free body diagram of this part, this becomes this is J, this is K, and this is Jy support reactions, this is Jx, this is Ky, and this member is Hi, this is H, this is H. So, this member is Hi. So, this force will be F of Hi, and this force is F of Hg, F of Hg. Okay. Now, and one more, you this and this force will, this is member Ik. So, this is force Ik, and another is, this is force Gj, force Gj. Okay. and their line of action, they will meet. If we join together, they meet here, and this point is point G, this point is point G, this point. Okay. Now, this is the free body diagram of FBD of 1 1, section 1 1. So, this section is 1 1, section 1 1, right. Now, let us find out, let us apply the free body. Once we have the free body diagram, let us apply the equilibrium condition on this free body diagram. But before that, what we need is, we need this angle, and also this angle. Okay. Now, suppose this angle is theta 1 and this angle is theta 2. So, all the dimensions are given. You can verify that theta 1, which is the smaller one, theta 1 comes around 35.75 and theta 2 is 73.5. Okay, that you can determine. Just apply simple trigonometry on this. Okay, because all these dimensions are given. So, this is theta 1 and theta 2. These are required because once we take the forces, summation of forces in particular direction, we have to take the components. Okay. Now, we need to determine force in member IK. Okay. Now, how many unknown we have in this figure? We have, these are the support reactions which are known. We have, this is unknown, this is unknown, then this is unknown, this is unknown. Okay. Now, if we take summation of Fx is equal to 0 and summation of Fy is equal to 0, then what happens? Then still all these unknowns will be there, right. Now, instead of that, let us take summation of moment about point G is equal to 0. Now, if we take summation of moment about point G, then what will happen? If this force, the line of action of this force passing through point G, so it won't contribute, this will not contribute, this will not contribute. Now, line of action of Fgj, that is also passing through G, so this will also not contribute. Line of action of Hj, that is also passing through point G, so this will also not contribute. So, if we take moment about J, the only forces that will contribute to this moment are Jx, then Jy, and then Ky, and this force member, force in member Ik, this one. Okay. Now, all these four forces, only one unknown. We know Jx and Jy, just now we determined, and we know Ky also determined, and we need to determine only the Ik. Now, summation of, so next step would be summation of M with about G, that is equal to 0. Okay. Now, all the forces are determined, the dimensions are given. If you do that, if you substitute that, then what we get is Fik is equal to this. Okay. That exercise, just substituting all these values and arriving at these values, I leave it to you. But the main important point, here is we have taken moment about G, so that the forces, all the forces, the contribution of all these forces becomes 0. The only contribution we get from this. So, now we have the member force. The force in member Ik is determined. Okay. Now, another force we need to determine is Hk. We need to determine the force in member Hk, this as well. Now, in order to do that, let us take free body diagram of joint K. Now, if we take free body diagram of joint K, what are the forces we have in this free body diagram? This is joint K. So, first is vertical reaction, which is Ky, and then we have this this Jk, Jk, and then this is Hk, which is acting at an angle theta 1, and then Fik, which is acting at an angle theta 2. Okay, this is theta 2 and this is theta 1. Okay, now only unknown is this is known, this is okay, then Hik just now we determined, this is also known, only unknown are this and this. Now next step is we take the component of the forces in x direction or in y direction and take the summation in that direction, all the forces is equal to 0. So if we take summation of Fy is equal to 0, then what are the components? We have the Ky, component of Ik, component of Hk. There will be no component of Jk because it is horizontal direction, and if you do that, then finally again this part I leave it to you. Hk is equal to 53.9 kilonewton minus. So these are the forces in two member. So this is the previous example was where your application, it was purely method of sections, all the member forces are determined using method of sections, but as I say in a most economic way will be if you apply wherever method of section or method of joints both together in the same problem. This is the second problem, second example was the demonstration of that. Okay, that's what for today. So, but if you take any structural analysis book, there are many problems. Some of them are very easy, some of them are very tricky. What important is as a concept wise, there is nothing new. You draw the free body diagram and apply the equilibrium conditions, right? What is important here? Then which free body diagram to consider? That is important. Which joints to be considered, which section to be taken, and that sense there is no guideline for that. That sense you have to generate in yourself, and that sense will come as you attempt more and more problems. Okay, so my suggestion is please go through the books and solve some of the exercise problems. This week we discussed how to determine the internal forces in statically determinate truss. Now that we are interested in two kinds of response, internal forces as well as deflection. Next week what we'll do is we will see how to determine deflection in statically determinate trusses. With this, thank you.